Welcome to the deep dive. Today we're jumping into something huge, a really pressing global issue. Microplastic pollution. I mean, these tiny plastic bits are, well, they're everywhere. In our oceans, rivers, even, and this is the unsettling part, our drinking water. But what if the solution, or part of it, was actually hiding right under our noses? Maybe even in the kitchen. We're looking at two pretty common plants today. And it kind of comes down to them being, well, sticky.
It is pretty amazing, isn't it? The sheer amount of microplastic out there is just vast. And it's a real worry, not just for fish and oceans, but potentially for our health, too. Finding ways to tackle this that are effective, but also crucially safe and biodegradable. That's the challenge. And that's really our mission for this deep dive, unpacking how these natural remedies, these plants, could actually be a game changer.
Okay, so let's really get into the problem first. You said pervasive. Just how bad is it? How deep do these microplastics go into our water?
Oh, they're incredibly widespread. It's not like they stick to one place. We find them everywhere, literally. Deep oceans, lakes way out in the middle of nowhere, and yes, even treated tap water sometimes. It's this ubiquity that really spurred on researchers like Rajani Srinivasan and her team. Their work has been laser focused on finding safe, specifically plant-based ways to deal with water pollution. And they've been at this for a bit. Their earlier work looked at okra, fenugreek, even tamarind extracts in the lab. Dr. Srinivasan actually presented some of this initial research back at the ACS spring meeting in 2022. So it shows how this work has been building.
That's really interesting. You mentioned sticky before. Let's unpack that.
Yeah.
Is it really just about, the slime from okra or that gel you get from fenugreek? How does that actually fight microplastics?
It sounds almost too simple, doesn't it? But the science behind it is quite elegant, actually. These plants, they contain specific things called polysaccharides. They're basically natural polymers. Think of them like tiny molecular nets, really effective ones. When you put these into water with microplastics, the polysaccharides essentially, they grab onto the plastic particles. This makes the plastics clump together, forming bigger, heavier bits. And once they're clumped like that, they get dense enough to just sink. Makes separating them out much, much easier.
Right, so the stickiness makes them clump and sink. That makes sense.
Exactly. It's the science behind the slime, if you will.
So they figured out this mechanism, but how did they actually, turn that into something usable? Did they just talk about it, or did they, make these things?
Oh, they absolutely got their hands dirty. That's part of what's so neat about this research. The method itself is surprisingly straightforward. They made these purifying powders themselves. For okra, they basically sliced the pods, soaked them in water to let the good stuff dissolve out. For fenugreek, they blended the seeds in water, let it sit overnight. Then they carefully took the liquid extracts from both and dried them out into these fine powders, almost like something you could do in a kitchen, albeit a bit more precisely.
Wow. Okay, so they have these powders. What happened when they first tested them? You mentioned lab tests in pure water. Did it work well straight away?
The initial results, especially in that clean, controlled water, they were very promising, really encouraging. They figured out the best amount was about 1 gram of powder per quart, so 1 liter of water. That seemed to be the sweet spot for trapping the plastics. And in terms of numbers, over an hour, the dried okra powder removed something like 67% of the plastic. Fenugreek was even better. It pulled out an impressive 93%.
93%? That's huge.
It really is. And they also tried mixing them, a 1-to-1 mix of okra and fenugreek powders. That combination hit 70% removal in just half an hour. Pretty efficient.
That's incredibly fast, too.
Yeah.
Now, you mentioned earlier there's a synthetic polymer, polyacrylamide, that's commonly used now. How did these natural ones compare?
Ah, yes, that's a really key comparison. And this is where it gets really interesting. These natural plant polymers actually performed better in their tests than the polyacrylamide.
Better? Seriously?
Yes, which is significant, right? It suggests we might not just have a safer option, but potentially a more effective one, at least for certain types of microplastics or conditions.
That's a major finding. Okay, so they've got great results in clean water. What next? Did they try it out in, actual dirty water from rivers or the ocean?
Exactly. That was the crucial next step. You have to see how it works in the real world, not just the lab. So they took these plant extract powders and tested them on real water samples collected from different places around Texas, water known to contain microplastics.
How'd that go? Did it work as well?
Well, this is where it gets a bit more nuanced, actually. The effectiveness, it changed depending on where the water came from. For instance, Okra powder seemed to work best in ocean water samples. It removed about 80% there.
Right.
But fenugreek, that one really shown in groundwater samples, hitting between 80 and 90% removal.
Huh, interesting difference.
Yeah, and that 1.1 mix, the combination of okra and fenugreek, that performed best in freshwater samples, like from rivers or lakes, around 77% removal.
So why the difference? Any ideas why one works better in salt water and another in groundwater?
The researchers have a hypothesis on that. They think it's likely down to the microplastics themselves. Different water sources probably have different mixes of plastics, different types, sizes, even shapes. And that variety likely affects how well each specific plant polymer can, grab onto them. It sort of raises this interesting point about maybe needing to tailor the solution depending on the specific water source you're treating.
That makes a lot of sense. Tailoring the solution. So pulling all this together then, what's the big takeaway? What does this all mean for, say, the environment and our health?
I think the implications are pretty significant. The really critical benefit is that these okra and fenugreek extracts are biodegradable. They're non-toxic. That's a huge advantage over the synthetic chemicals like polyacrylamide that are currently used, which can sometimes leave behind potentially harmful residues. Rajani Srinivasan, the lead researcher, she put it really well. She said, essentially, that using these plant extracts cleans the water without adding new toxins, so it reduces the potential long-term health risks for people drinking or using that water. That's the goal, right? Cleaner water, healthier future.
Definitely. It sounds incredibly promising. When you hear about this potential using simple plants like this, what really stands out to you? For me, it's just, it's amazing that everyday things, plants like okra and fenugreek, could hold such a potentially powerful answer. An answer to this really complex global problem like microplastic pollution. It feels so simple, yet profound. Nature's own cleanup crew.
It really does shift your perspective, doesn't it? And it leads to that bigger question. If common plants we cook with have this hidden power, what other natural solutions might be out there, just waiting in plain sight? What other, bio-inspired innovations could come from looking more closely at the natural world around us? It really opens up possibilities, I think. What does it make you wonder about?
That is a fantastic question to ponder. Definitely something to keep thinking about. Keep exploring, stay curious, and continue your own deep dives into this surprising world we live in.